All right, so what we've just said is that if I want the derivative of a product, I have to use this crazy rule, f prime g plus fg prime, or at least that's what appears to be the case. So now what we're going to do is we're going to look at the proof of this. The proof is on page 119 of your book. You do not have to know the proof. You have to know the result and be able to use the result, which we will do next. However, you gotta see this because it's awesome, okay? So first, a couple of things. So this is the book, page 119 right here. All right, you can look on your book if you want, but I'll try to get it all in here. So one thing to notice right away is that they use a little bit different notation here. So they say, instead of fg prime like this, they say the derivative of the product of u and v, all right? And then, so the way they write this, like they have u dv dx, so that's like f g prime, right? dv dx is going to be their g. Like if this is f and this is g, then this is f and this is g prime. All right, just to compare the way I'm writing it. And then their v is my g, so g, and then their du dx is my f, so that's going to be f prime. All right, so what they write is the derivative of fg, so fg prime, is equal to fg prime plus gf prime. So hopefully you can see that algebraically that is the same as what I wrote here, f prime g plus fg prime. All right, I just rearranged the letters because it matches the quotient rule better, so we're gonna learn it that way because it'll be a little easier to work with. Okay, now, how are you going to prove this? How am I going to prove something about the derivative of a product of two functions when I don't even know what those two functions are? Well, like all proofs involving derivatives, you start with the definition of the derivative. So the definition of the derivative of this product of u and v would be u of x plus, the limit as h approaches 0, u of x plus h, v of x plus h, minus u of x, v of x over h. You will not have to do this because your book has done this for you. Somebody did this, somebody very clever. Perhaps it was Leibniz. Who knows who did it? I don't know who did it because I'm not a historian. All right, but somebody figured this out who was very, very clever. And so basically what this limit statement you're looking for, it's just like f of x plus h minus f of x, right? But instead of f, you're using uv. So uv of x plus h is u of x plus h times v of x plus h, blah, 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 okay? So now they go from this line to this line. So I'm just going to show you that it still says derivative of uv, okay? So I can scooch this over and we can see it all. It equals the limit as h approaches 0. So believe it or not, this big, long, crazy fraction is identical to this one. They just stuck something in there. So this is a standard mathematical technique. I've talked about it before. It's a mathematical trick, and it works like this. So this part of the fraction is here, and this part of the fraction is here. So what's the only difference? They stuck this in here. So what is that, and how do they get to just stick it in there? Well, since it's negative u of x plus h v of x plus u of x plus h v of x, these two terms actually cancel out. So if you work back, they would be 0, right? So what they've done is they've taken 0 and split it out into two opposite quantities that ultimately equal 0, right? So this is, again, like the quantum vacuum. We have a total vacuum in space. You can spontaneously manifest a particle and an antiparticle. This happens all the time. Since the particle and the antiparticle cancel each other out, you still actually have empty space. However, there are particles in it, right? So that's one of the mysteries of quantum mechanics. And here's like the mathematical analogy, that I can always add in something as long as I subtract it out at the same time. So we've actually seen that in some other proofs before. I forget which one. So but it's a clever thing you can do. Add in and subtract out. All right, but why those? Why put in those things? So the idea is then you are creating a factoring by grouping that you can do. Because you have this u of x plus h, and then u of x plus h again. So what we do is we factor that u of x plus h out here. And the reason for that is that what you end up left with is the v of x plus h, which is here, and the v of x, which has a negative sign and is here. And the reason why that is helpful is because this now is just the derivative of v, right? It's the limit as h approaches 0, v of x plus h minus v of x over h. So this is just v prime right there. And in fact, if I take the limit as h approaches 0 of u of x plus h, as I do substitution, substitute 0 for the h, I just have u of x. So here's already u v prime, right? The f g prime that we wanted to have. So those things are showing up. And then basically, and that's why we add in these, somebody clever added in these terms, because they allow what you want to show up. And that's sort of the kind of reasoning that people use. So now on this pair of terms, what we factor out is the v of x, right? So that v of x is here. And then so this is really factoring by grouping. And then the u of x plus h, the u of x plus h is here, and the minus u of x is here. So everything that's up here is here. You can sort of look at how the h breaks down, essentially because we're breaking this whole thing over this plus sign. So this plus sign breaks it into two sort of major expressions. And so each of those two major expressions, since we're breaking it over a plus sign, they each have their own denominator. However, within each term, what you have is multiplied because we factored out that u of x plus h. So since I have a product of terms here, we only need one h, right? So if I multiply this all back out, I'm going to get an h in the denominator. If I multiply this all back out, I'm going to have an h in the denominator. And then when I add them together, my two h's are just going to give me, they'll just be a like denominator. So you can sort of study how the h falls out. But essentially, we're just breaking into two fractions and then factoring something out of the top of each fraction. So that's what's going on there. All right, then what they do is break up the limit. So we've done this before. I have the limit of a product and some sums. Now, unlike the derivative cannot be broken into a product, but the limit can. So that's part of the difference in how this works. So then I have limit as h approaches 0 of u of x plus h, that's here. Right, that's this one. Then I have the v of x plus h minus v of x, that's here, but we're breaking the limit up into all those. For v of x, they could have also put here limit as h approaches 0 of v of x, but what they're saying is, since the limit variable does not match the variable of the expression, the limit as h approaches 0 of v of x is just already v of x. In other words, they already evaluated this one by substitution. For some reason, I would have kept the limit here. Right, but this limit is just going to be v of x because there's no h in it. And then the limit of h approaches 0 of this factor is here. So all of these factors are split up here, and they evaluated one of the three limits. All right, then, okay, this limit you do by substitution. Substitute the 0 for the h, and we just get u of x. This one we already said is the definition of the derivative of v. This one is already just v of x, and this one is the definition, right? Limit as h approaches 0, u of x plus h minus u of x over h. That's the definition of u prime of x. So that is how this rule is derived. That's what they have here. U v prime plus v u prime is equal to u v prime. And then we just restated it using different variables in a different order. The derivative of the product is equal to f prime g plus f g prime. That is the product rule. You do not have to know this proof, but it will grow your mind if you study it. Just like look at it and go, dang, that's amazing. And your mind will grow. All right? Now, you have to know this. And know, as you are aware, is my euphemism for memorize. But you have to know it. You have to understand it. We will look at how to use it in the next videos. And, as far as memorizing it goes, once you use it a few times, you're going to remember it. That's, to me, is how memorizing really should work.